Yes, student, the next content is chemical properties of carboxylic acids. Student, carboxylic acid, as the name is suggested already, the whole compound name is carboxylic acid. That is what? It is simply acidic in nature. Now, what is the reason of acidic nature of carboxylic acid? So, you can find its structure R, C, this is double bond O, this is O, and this is what? H. Okay, this is a simple or common carboxylic acid. Okay, where it is dissolved in aqueous solution. Student, you can check here. OH containing carbon is further attached with one more oxygen, which is form double bond with carbon. This oxygen is more electronegative. You know clearly the presence of one pi electron pair, okay, is weak in nature. Therefore, the more electronegative carbon atom attracts this pi electron pair towards itself. Thus, the complete shifting of pi electron takes place towards oxygen. Thus, this oxygen becomes electronegative. Now, being this oxygen becomes electronegative, the carbon becomes electropositive, okay, which is attached again with O and H. Now, due to deficiency of electron on carbon atom, okay, now the shifting of electron pair takes place towards carbon atom. Are you getting? And therefore, the OH, now the O will become electron deficient, so the OH bond pair is getting shifted towards oxygen atom. Thus, it can easily release R, C, getting? This is become what? O and what? Anion. And now the shifting is takes place, therefore it will become RCO, okay, anion, plus this become what? H cation. That is, it can simply release what? H cation. Are you getting? Being the H cation is released in the aqueous solution, carboxylic acid is acidic in nature, because any of the compound which is able to provide H cation or proton is called acidic in nature. Okay. Now we can discuss comparison. Comparison. Okay. Carboxylic acids are weaker acid. Okay. But weaker acid in which form? As compared to mineral acids. Mineral acids. Now, what are mineral acids? These are what? HCl. This is what? H2SO4 and what? HNO3. Actually, why? Okay. Reason. Okay. Mineral acids. Okay. In aqueous solution. Provides what? Large number of H cation. They provides what? Large number of H cation. Now, what is the reason behind it? You can take simple example of HCl. Here, student, in Cl, the proton charge is 17, while in hydrogen it is what? Only 1. That is, nuclear attraction force is very strong. So, the complete shifting of electron pair due to very strong attraction force of Cl, which in turn we are calling what? Electronegativity. Okay, completely use H cation and Cl anion in aqueous solution, and this is in what? Large quantity. Therefore, mineral acids are stronger acid as compared to what? Carboxylic acid. Are you getting? Here, student, one more thing is there. What is this? Here, R, being electron releasing nature. it increases electron density on oxygen atom. Being it increases electron density on oxygen atom, now it becomes highly unstable and therefore it takes its hydrogen cation in aqueous solution. Are you getting? And one more thing, the formation of dimer. You know that the carboxylic acids are able to form dimer, and due to this dimerization, the release of H cation becomes difficult. This is because the hydrogen bond is getting formed between two carboxylic acid molecule, which we have checked in the earlier content, that is earlier video. Okay, so there are two reasons. What? Electron releasing nature of R increases electron density of on O, therefore O become what? More electronegative, that is unstable, and due to the instability it has tendency that it again attracts what? H cation. That means if you see, there is an equilibrium, that is R, C, O, O and H. Okay, aqueous solution gives R, C, O, O anion plus what? H cation, and there is what? Actually an equilibrium developed between undissociated carboxylic acid and dissociated, that is ions of carboxylate ion and hydrogen cation. Getting? And one more reason is what? Dimerization. Getting? Which we have already discussed. But the comparison number 2, comparison, okay, number 2, as compared to phenol. Now you know phenol is also more acidic in nature. Now, as compared to phenol, carboxylic acids are more acidic in nature. Now, what is the reason of carboxylic acid are more acidic as compared to phenol? So student, you can check again here. What? R, C, double bond O, O and H. It is getting converted into R, C, double bond O. Okay, and this is what? O anion. Now, being there is what? Double bond present. That means there is chances of resonance. So, one more, the resonating molecule is possible by shifting of lone pair and what? Pi electron pair. So, after shifting, it will give resonance number 1 and the resonating structure number 2, this one, double bond O. Getting? Now, this is the resonance 1 and resonance 2. That is, it have two canonical form. Okay, carboxylic acid, or say you can say carboxylate ion. Carboxylate ion. Okay, have two identical resonating form. Okay, which makes it more stable. Now, if it will become more stable, then it will show the lesser tendency to attract H cations. That means in aqueous solution, the H cation will present freely. Okay, why? Because these resonance will stabilize themselves. That is, a resonating form or canonical form can stabilize themselves. So, carboxylate ion have two identical resonating form which make it more stable. Student, you know that the resonance is directly proportional to stability. Okay, while phenol, okay, forms phenoxide. Phenol form phenoxide, which gives high numbers of canonical form. Okay, but the problem is what? But they are not identical. They are not identical. Student, actually here the identical form shows more stability, but if even the resonance structure are of 5 numbers, that is large number, it has only 2 numbers of resonating structure. Look at here, only 2 number of resonating structure. Okay, while the phenoxide forms 5 number of resonating structure. So the phenoxide should be more stable as compared to carboxylate. But we have one more characteristics of resonance, that if the canonical form are identical in nature, okay, then will show more stability, and due to more stability, the carboxylic ion doesn't shows the attraction of H cations, while the phenoxide ion although forms high numbers of canonical form, but none of them are identical. Therefore, it is weaker acid as compared to carboxylic acid. Are you getting? Student, actually there are many work to do about the acidic nature of carboxylic acid. Like here, if we attach electron releasing group and electron withdrawing group in carboxylic acid, then they will affect the acidic nature of carboxylic acid, which we will deal in next video and next class. Till you do work, okay, how the electron releasing group and how does the electron withdrawing group, if attached with the carboxylic acid, okay, affects the acidic nature of carboxylic acid. Getting? Say the releasing of H cation provides acidic nature of carboxylic acid. If the electron releasing group is present, then it will increase electron density, so the releasing capacity will decrease. And if electron withdrawing group is attached, then it will attract electron from what? Carboxylate ion, and therefore it will increase the acidic nature. So we will discuss in next period. But here this question is very important. This phenomenon is very important for competitive exam. Okay, so you have to find it. Yes, even they are more acidic as compared to what? Alcohols. Okay, yes.